Okay guys, so today we're going to talk about our segment addition postulate. We're also going to discuss measuring segments, what it means for segments to be congruent, and then we're going to use the midpoint of a segment to find the lengths of certain segments, also using the segment addition postulate. So let's go ahead and get started by talking about measuring segments. So in this case, we have a segment here from A to B. And the distance between 2 points A and B is written as the length. So the length, of segment AB. Now, to go ahead and put in that segment, we're going to go to our formula tool. We're going to go pi, and we're going to scroll down where it says segment. And I'm going to click the pi button again to get it to go away. And then I'm going to put the letters AB under that line. So the length of segment AB, or we also generally will represent it as simply AB. So whenever you see AB without any notation over it, it means the length of segment AB. So if we look at our picture here, we have segment AB, and we can see that it is 1 from 1 to -3. So we got 1, 2, 3, 4 units. All right. So the other way we could have done that, of course, is to do 3 minus -1 to get 4. So we're going to go ahead and put that there. Oops. No biggie. All right. So moving on to congruent segments. So we can see here in the picture, we have segment AB, which again is still 4 units long because we got 1, 2, 3, 4. And then we have segment CD, which is also 4 units long. 1, 2, 3, 4. All right. So what we're going to say here is that the length of segment AB is equal to the length of segment CD. Then the segments are congruent. The way we write that is by saying that segment, so we got to go into our formula tool again. And because I know I want to be able to see this for a little bit, I'm going to scroll down a little. Let's make it a little bigger, and then that way I can uncover the writing. All right, so text box here. And we're going to go to our formula tool. And again, I am color coding a little bit, not as much as I normally would. Segment, and that's going to be segment AB. And I'm hitting my right arrow to get out of the line segment. And then we go down here to my congruent. So segment AB is congruent to segment CD. Okay. All right, so now we're going to move on to the segment addition postulate. And you can remember when we did our vocabulary lessons, we stated that the segment addition postulate is essentially the lengths of 2 segments can be added together to get a longer segment. And the fancy way of writing it is if A, B, and C are collinear points, and B is between A and C, then the way we say that is that AB plus BC, and I'm going to be making this a little bit color-coded. All right, BC. And I'm going to actually change this color, guys. So I am color-coding this one. Is going to be equal to AC, the length of the whole thing. So if we look at the picture that we have here, the way it will be is I'm going to use my highlighter tool. So I'm going to highlight with red, AB. Okay. And then we have BC. So when I add these together, I get AC, the total length of the entire thing. So we're going to use that information and apply it down here. So we have used the diagram below for questions 1 and 2. Now during this next portion, you will need to remember that what I will be expecting you to show your work will be what we do in this assignment. So please make sure that you show the bare minimum. In class the first day we did 1, 2, 3, and 4. And then for the second lesson, it's going to be 8, 9, and then hopefully we can do 11. We'll see what we can come up with in class, but I will let you know. All right, so we have our line segment PQ. And again, I'm going to be using some color coding here. So we have our PQ. And we have our QR. And then we have our PR. And I'm just going to put it over the top like this. So let's go ahead and write our equation out. So we have PQ plus, and it's going to be QR is going to be equal to PR. All right, so that's the equation we're going to be looking at for both number 1 and number 2. So on number 1, we have if PQ is 9, so I'm going to highlight PQ, is 9, and QR is 28, then we need to find PR. All right, so again, if PQ is 9, and QR is 28, then that's going to be equal to our PR. If we add those two numbers together, we will get 37. So PR is equal to 37. Now in this instance, units are not required to be given back because no units were given to you in the first place. So whenever units are given to you, you do need to make sure that you give units back. Number 2, if QR equals 17 and PR is equal to 21. Let's click on this. They want us to find PQ. Alrighty, so let's go ahead and do that. We have our equation already ready to go. So it is going to be PQ plus QR, which is, 17. So I'm going to go ahead and put that there, 17. And that's going to be equal to the total length of 21. So PQ plus 17 is 21. We'd have to subtract 17 from both sides. And so therefore, we have PQ is equal to 21 minus 17, which is 4. Right? Now we're going to move on to number 3, EG equals 71. Find the value of X. So in this case, we're going to go ahead and make a list of our givens, and then we are going to also highlight what we're looking for. So it looks like for now, we are looking for the value of X. The value of X. So we're going to use the same scheme. So we have EG is 71. We have EF, and then we have FG. Okay. And so then first thing we're going to do is we're going to go ahead and make a list of the information that we know, and we call this our list of givens. So I'm going to make a list of givens. Let's say given, enter, and I'm going to go ahead and uncenter that. There we go. So we know that EF is represented by 8x plus 7. So EF equals 8x plus, minus 17. It's the third or fourth time today I've done that. And then we know that FG is going to be equal to 5x minus 3. And finally, the total length of the segment, EG, is going to be 71. So now we did our list. We're going to do our formula. So our formula is going to be EF plus FG will be equal to, and it's going to be EG. So EG. So that's our list. And now we're going to do our formula. So again, I'm going to be using the text tool so that I can keep everything nice and aligned. We have to do our substitution. So let's go ahead. We have EF, which again is 8x minus 17. And then we're going to add FG, which is going to be represented as 5x minus 3. And that's going to be equal to our total length of 71. So the first thing we need to do in this case is, okay, so you may have noticed a slight format change. I just wanted to make it a little neater. And then I'm going to go ahead and add highlighting to get the color coding back where it was. So let me go ahead and color code here. Color code this one. And this one. So I will pause while I do these kind of color coding things as we go. So our first step here is going to be to make sure that we combine like terms. So we have as our like terms 8x and 5x. And then we have negative 7 and negative 3. All right. So that means on our next line, we're going to go ahead and combine those. When we combine 8x and 5x, we will be given 13x. And when we combine negative 17 and negative 3, we get 20, negative 20. I am going to be needing to add 20 to each side in order to isolate the 13x. Now this step is does not necessarily have to be shown. But it's not a terrible idea to show it if you're not sure that you'll remember what you did when you look at it later. So if you think you might want a reminder of what we did later, make sure you go ahead and include this part in your notes. Okay. All right. When I add those together, I will be given 13x is equal to 91. And okay, there's an extra 3. Our next step here is to go ahead and divide that by 13. Now, normally we would want to do this with a fraction. However, it is a little bit difficult to do here with this. So what we're going to do is we're simply going to put the divided by sign, which is right here. I'm going to put 13. And again, I'm going to put it over here as well so that it represents being done on both sides. Now remember again, I don't necessarily need you to show me this every single time, and in later problems I'm going to not do it, but at least you can see that it was here the first time and you can copy it down later. Alright, once we divide both sides by 13, we will find that x is equal to 7. Now I will be using Desmos for calculations in this class. So because it's right here, okay, and everything shows up, you are welcome again to use whichever calculator you please. All right, number 4, if TV is 14x minus 8, find TU. All right, so what we're going to do is, let's go ahead and do some color coding. So we have the whole thing is going to be TV. So TV, and then we have TU, and we have UV. Oops. UV. So the first thing we're going to do is we are going to list our givens just like we did the previous time. Again, this is something you're going to want to do on every problem. So our given. And if you are interested in how I'm underlining, it is Control U, but you can also use the toolbar up in the top here. All right, our first given is that TU is 9x plus 2. So let's go ahead and include that information. TU is equal to 9x plus 2. And then we have UV here. UV is going to be equal to 5. And then finally, the full length of the segment, which is TV, is going to be represented by the expression 14x minus 8. And now it's time to go ahead and make our formula. So we have our TU plus our UV, and that's going to be equal to TV. Now, again, if we read the problem here, it tells me to find TU. So I'm not going to be able to just stop once I've solved for x. Okay, we need to do TU. All right, so let's go ahead and do the work for this. I'll make this a little bit smaller. Formula tool. TU, which is 9x plus 2. And that's going to be plus UV, which is 5. And that will be equal to TV, which is 14x minus 8. All right. So again, first thing we need to do here is combine like terms. So our like terms on the left-hand side are just 2 and 5. And then we have 9x stays the same. Nothing's going to happen to the right-hand side. So we are going to end up with 9x plus 7 is equal to 14x minus 8. All right, so now we have several options for our next step. We could subtract 9 from both sides. We could subtract 7 from both sides. We could subtract 14 from both sides, or we could add 8. Now, I personally will usually do anything possible to avoid dividing by negative numbers, so I'm going to try and keep my x positive. So what I have elected to do is I'm going to go ahead and make sure that all the x's end up on the right and all the constants end up on the left. So let's go ahead and start by subtracting 9x. And again, under normal circumstances, you will not likely have to do this part where you show this step. At some point, though, if it does show that if you do seem to be struggling, I will go ahead and make sure that you start showing that step. I'll let you know. Okay, so once we complete that step, we are left with 7 is equal to 14x minus 9x is 5x, and it's going to be minus 8. And then from there, we have to add 8 to both sides because we need to get x by itself. That's the point of solving an equation. Oops. Again, I continue to use the formula tool because I want to keep it formatted. And I'm going to end up with 15 is equal to 5x. When I divide both of those by 5, then I'm going to end up getting 3. All right, let me go ahead and do the divide by 3. Sorry about that, guys. I had a minor technical glitch. Had to fix it. All right, so we're going to divide both sides by 3. And again, as you use the symbols, they will show up. Sorry, not divide by 3, divide by 5. All right. Again, like I said, I was about to say, as you do the symbols, they start showing up top. And so if you're using them regularly, you don't have to do it over and over again. All right, so when we do that, we get that 3 is equal to x. However, if you recall, we weren't asked to find x. We were asked to find TU. So what we need to do is go ahead and substitute 3 in for the expression 9x. So we have our TU equals, And that's going to be 9 times 3 plus 7. And I'm going to show you how you can get this into Desmos quickly. You just highlight it, copy with Control C, paste it into Desmos with Control V. Oops, and that should have been a 2. And then we get 29. I need to fix that. All right, so that equals 29. Okay, now moving right along. I'm not going to color code the next two because I only needed to do that for one of each, but I will still be doing the same process as well as some highlighting and indicating of where things are. So number 5 says if JL is 5x plus 2, they want us to find JL. So again, what we're going to do is we are going to start by making our list of gibbons, and I'm going to go ahead and do that in whatever color I want. And I am going to do the underline. You don't have to. We know that JK is going to be equal to 27. And we know that KL is going to be equal to 3x minus 1. And we know that JL, the entire thing, is 5x plus 2. We need to make our formula. So we're going to go ahead and write our equation of JK plus KL is going to be equal to the full length JL. Now we're going to do our substitution, which I'm going to do in a different color. The dark red. Why not? All right, so let's enter our formula. So we get 27 plus 3x plus 1, or minus 1. And that's going to be equal to 5x, oops, 5x plus 2. All right. Excuse me. And now we need to combine like terms. So we have 27 and negative 1. So I'm going to go ahead and highlight my like terms here. So 27 and negative 1. All right, so when I combine those like terms, I'm going to end up with 3x plus 26, because 27 minus 1 is 26, is going to be equal to 5x plus 2. And then what I'm going to do, let's go ahead and continue on. All right, so now I need to choose which of my next steps I'm going to do. I am going to go ahead and subtract 3x from both sides because, I prefer to keep the x positive, but if you subtracted 5x from both sides, it would still work. I know in one class we did that. 3x, okay. And again, I'm just making this neat. All right, so when we do that, we are left with 26 is equal to 5x plus, oh, sorry, not 5x, 2x, because 5 minus 3 is 2. Now we're going to add 2 here. Okay. And then our next line, we're going to go ahead and subtract 2 from both sides because in order to get all of the constants together, we need to do inverse operations. So I'm going to go ahead and subtract 2 from each side. And then what I'm going to do is end up with 24. And again, I'm going to be using my formula tool. So we have 24 is equal to 2x. We are going to then divide both sides by 2. Again, I'm using the formula tool. I'm going to put divide by 2. I'm going to space over, and again, I'm going to put divide by 2. This is how I would want you to show that step. Right. Now, when we divide both sides by 2, we are left with 12 is equal to x. But again, they did not ask me to find x. They asked me to find JL. So I need to substitute 12 in. the equation for JL. And actually, let's go and do that in the dark purple. So JL is 5x plus 2 equals, so it's going to be 5 times x plus 2. And if we take 5 times 12, that's going to be 60 plus 2 is 62. Again, you can highlight, copy and paste into your Desmos calculator if you so desire, but that does show it is 62. All right, moving right along. If CE is 7x plus 4, find the F value of x. So again, I'm going to highlight what am I looking for so I don't forget. And then I have if CE is 7x plus 4. Alrighty. So I'm going to go ahead and do this in a different color. Why not? I like colorful notes. Again, we are going to make our list of givens. Oops. And we are given CD, and that's going to be equal to x plus 3. And we're going to have DE, and that's going to be equal to 8x minus 9. And we have our total length, which is CE, and that's going to be represented by 7x plus 4. And then we need to give our equation, or our formula. So CD plus DE is equal to CE. And then we're going to go ahead and move right along, and we're going to go ahead and do the equation. So let's get that done. So don't forget, when we are substituting, we should be using parentheses. I'm using my formula tool again. So I have x plus 3 plus 8x minus 9. And that's going to be equal to 7x plus 4. And we'll close those parentheses. Scoot everything over just a bit. All right, again, we need to combine like terms. And again, here we have like terms of x and 8x. And then we have like terms of 3 and negative 9. So we need to make sure we combine both of those sets. So x plus 8x is going to be 9x. And positive 3 minus 9 is negative 6. And then we didn't do anything to the right-hand side, so we're going to leave it as 7x plus 4 for the time being. All right. So now I'm going to go ahead and subtract 7x from both sides so that I can have my positive x. Here we go. Set it over. Alrighty. And then we're going to end up with 2x. 2x minus 6 is equal to 4. And now what we need to do is we need to add 6 to both sides so that we can get the constants together, and the x is already isolated by itself on the left-hand side now. So we add 6 to both sides. And I'm using a lot of the math tool. And that will leave us with 2x is going to be equal to 10. We will then divide both sides by 2. Division symbol. And I'll put one here too. All right. Oops, I meant to. I unfortunately am thinking just a little too far ahead. And that will give us that x is going to be equal to 5. And in this case, that is what they asked me for, so I can stop here. All right, if sk is equal to 13x minus 5, ky is equal to 2x plus 9, and sy is equal to 36 minus x, find each value. So we have to find all of these things, every single one of these, all right? So that's what it's asking us to do. So let's go ahead and get started by listing our givens. And I guess I want to do, let's do purple again. All right. So let's list our givens. And yes, I do know they are listed for us over there, but it's a good habit for us to be in. We need to continue to list our givens, even if they appear to be listed for us already. So 13x minus 5, ky is going to be 2x plus 9, and sy is going to be 36 minus x. And then we're going to go ahead and put in our equation. So it's going to be sk plus ky is going to be equal to sy. All right, moving right along. We have our substitution. So sk is 13x minus 5. And then we are going to add, and I want to go ahead and use the formula tool, which I clearly forgot to do. 13 x minus 5. I'm going to add 2x plus 9. And that will be equal to our final expression of 36 minus x. From here again, I'm going to combine like terms first. So my like terms on the left-hand side are 13x and 2x. And then I have negative 5 and positive 9. So we're going to go ahead and combine those like terms. So 13x plus 2x is 15x. And negative 5 plus 9 is positive 4. And that's going to be equal to 36 minus x. All right, so I am going to add x to both sides because that is going to be the most logical decision. Mostly because it's easier than doing the 15. All right, so that's going to leave me with 16x. I keep doing that. 16x. And we have plus 4 is equal to 36. We are going to subtract 4 from both sides. And when we do that, we're going to end up with, let's see. All right, minor continuity error. You'll see I moved everything up here. The way I did that is I did select annotations, and I highlighted just the ones I wanted, and then I can move them all around together, so I don't have to worry about that highlighting getting moved. All right, so actually, let's do it again. Just a little bit. Now you see I picked up more than I wanted. All right, so we were subtracting 4 from both sides, which will then give us that 16x is equal to 32. We are going to divide both sides by 16, and most of the time that would be mildly annoying because 16 is a fairly large number for dividing by, but since it's a multiple of 16, it's not really a big deal. So this 16. And that is going to leave us with a final result of x equals 2. So x equals 2. Now, we need to take that information and plug it into sk and ky and sy. So we have our sk. Again, I'm going to do this in there. Sk is equal to 13 times 2 minus 5. And again, this is one of those ones where you can just do the substitution and run it through the Desmos calculator. And we get 21. So I'm going to put my cursor over here. It's 21. Then we will find that ky is going to be 2x plus 9, so 2 times 2 plus 9. And we get 13. And then finally, SY is going to be 36 minus x. Well, 36 minus x is going to be, sorry, I meant to put 2. It's going to be 34. I'm going to put 34. So that was basically how we apply the segment addition formula and postulate. Now we're going to use the midpoint as well and apply some information there. So let's go ahead and take a look at that. We have for the midpoint of a segment, and it says it is a point that divides a segment in two. So let's see, what does it divide it into? So let's put midpoint. And it's going to be 2 equal parts. So we want to make it 2 equal parts. Again, I'm going to make the colors different. 2 equal parts. A ray, line, or a line, ray, or segment that intersects a segment at its midpoint is said to bisect that segment and is called the segment bisector. Now again, we did discuss these terms the other day, so hopefully you still have your notes. If not, mine are on Google Classroom as usual. In the diagram to the left over here, blank is the midpoint of blank. So where's one is the midpoint? We have B. So here we go. B is going to be the midpoint of that segment. So the segment is segment AC. So I'm going to go here in my formula. I'm going to change my color so it matches. Segment. Hit back. AC. And then I'm going to get rid of some of this. All right. And then we have this line here, line L. And again, remember, we want to go ahead and make sure that we italicize our L by clicking the I up here. And it's going to be in lowercase. So line L is, one moment. Sorry about that, my blanks disappeared. So line L is going to be a segment bisector, is what they're looking for. Segment. Let's do it again. Oh, blue. Of, and this is going to be segment AC. We're going to segment AC. All right. So we're going to apply that information. So on number 8 here, it says if Q is the midpoint of PR, of segment PR, find the value of X. So the first thing, when they tell you that something is a midpoint, I want your first instinct to be go to your shapes tool, get a line, and mark those segments congruent. Okay. So now we're going to go ahead. We know it's the midpoint. That means PQ is congruent to QR. So let's go ahead and make our list of gibbons. I'm going to do it over here in the corner because there's more room. Yeah, that's a little bit unusual, I know, but we're going to do it that way anyway. All right. So let's list our gibbons. We are given that Q is the midpoint of segment PR, which means that segment PQ, oops, sorry about that, segment PQ is congruent to segment QR, which indicates that PQ, the length of PQ, is equal to the length of QR. And we are given that PQ is being represented by 7x minus 7x minus 16, and QR is going to be equal to 4x plus 2. Now normally this is where we do our formula. However, because of the observation we made a few moments ago, where it says PQ is congruent to QR, so therefore PQ is equal to QR, what that means is this is our formula. So PQ equals QR. This is super important to get used to, because when we see a midpoint, we want to remember that the two segments are congruent. So we're going to go ahead and we're going to do the math there. It wants us to find the value of x. So we're going to say that PQ, which is 7x minus 16, is going to be equal to 4x plus 2. Now the next step is to combine like terms by using inverse operations. We have nothing to combine on either side, so we can go straight to moving things. Again, I like to keep my x's positive, so I like to move from the smaller x to the larger x, no matter what. That is still optional though. You can do it the other way around if you wish. Nothing stopping. All right, so we have minus 4x. And that's going to leave us with 3x minus 16 is going to be equal to 2. Now our next step is to add 16 to both sides so that we can balance out this equation. So we add 16. Add plus 16 here. And that is going to give me 3x is equal to 18. If we divide both sides by 3 at this point, which is the next step, so I'm going to hit enter. Okay, so I'm going to go ahead and, like I said, divide by 3. You may notice that it looks a little bit different. Again, minor continuity error. But I decreased the amount of space between the lines so that it would take up less space. So x is equal to 18 divided by 3 is 6. And so x is equal to 6. So where I'm changing the space between the lines is up here. You don't have a specific amount of space you must have on this. All right, if GH is the midpoint of GI, then find GH. So first off, we mark them congruent because they are congruent. And we're going to go ahead and list our givens. And then our givens right now is going to be that since H is the midpoint of GI, that means GH is congruent to HI. So let's go ahead and put that in there. Segment GH. Oops. I did that again. Sorry, guys. Segment GH is congruent to segment HI, which again means, tells us exactly what we need to know, and that is that GH is equal to HI. We are given that GH is going to be represented by the expression 5x plus 2, while HI is going to be represented by the expression 9x minus 10. Again, because of the nature of the logic we were using, where we said GH is congruent to HI, so therefore GH is equal to HI, we already have our equation set up for us, so we're going to use it. No reason to not use something we already have. All right, so we have our substitution. We have 5x plus 2, and that's going to be equal to 9x minus 10. We're going to solve for x. All right, so let's go ahead and use our inverse operations to isolate x. The way I'm going to do that is go ahead and subtract 5x from both sides, again, because I would rather the x stay positive. That is completely up to you, but whichever way you like to do it, I recommend choosing that and sticking with it. It will make it a little easier. So you'll notice that unless you guys tell me otherwise, I tend to stick with the positive x whenever possible. And that's just because that's the way I like to handle it. So once I've added or subtracted 5x from both sides, I'm left with 2 is equal to 4x minus 10. I am then going to get that 10 to go away by adding it to both sides. So we're going to move that over. And finally, 2 plus 10 is 12. And that's going to be set equal to 4x. We need to divide both sides by 4. Again, doing the same thing we've been doing. Remember, if you're following along, you can actually just do the same exact things I'm doing. Copy the motions. And we're going to get that 3 is equal to x. But again, they did not ask me for x. They asked me for the length of GH. Now, normally what I do here is I decide which expression I'm going to substitute back in for because they are equal. And so therefore you can use either expression. Usually I do whichever one feels the easiest. So I find that multiplying by 5 is always easier than multiplying by 9. So I'm going to choose the actual expression for GH. So we have GH. So let's go ahead and open our formula tool. So GH is equal to 5 times 3 plus 2. 5 times 3 is 15 plus 2 is 17. So GH is equal to 17. We are again not given units, so no units must be returned. Number 10. It says that R is this midpoint of segment QS, and it wants us to find the length of segment QS. So first off, we will need to mark our congruent tick marks. We're going to make our list of givens, just like we're always going to do. Always list your givens. It will help. And so we are given that R is the midpoint of QS. So what that means is, by definition, is going to be that, again, like I've been saying in the previous problems, that QR is going to be congruent to RS, which again, by definition, means that QR is equal to RS. And then we are given that QR is going to be equal to 2x plus 16. And we are also given that RS is equal to 5x minus 17. Again, we already have our equation while we were listing what we already knew. And so therefore, we can go ahead and solve for x first. So we have 2x plus 16. And that's going to be a substitution, so let's go ahead and do that. And it's going to be equal to 5x minus 17. We are going to combine like terms, and I'm going to go ahead and subtract the 2x from both sides to maintain positive x's. So I'm going to say subtract 2x. Subtract 2x. And that's going to give me 16 is equal to 3x minus 17 And now I'm going to add 17 to both sides in order to balance out this equation. And that's going to be 33. All right. So I'm going to end up with 33 is equal to 3x. We will then do our next step of dividing both sides by 3. And luckily, 3 divided by 3, of course it's easy to do the one with the x, since anything divided by itself is 1. And we conveniently ended up with a lovely multiple of 3. So we have 33 divided by 3 is 11. And 3x divided by 3, and I have too many 3's here, is just going to be x. But again, it didn't ask me for x. It asked me to find QS. So one thing we know is that because these are congruent to each other, we know that it's going to be QR plus QS. They are equal to each other. So really we only have to find one segment and multiply it by itself. So the way we're going to show our work there is we're going to choose which one we think is easier to work with. I am going to choose, I'm going to do 2x plus 16. Mostly because it seems like that's probably the easier choice. So 2x plus 16 is QR. So let's go ahead and do it that way. QR is going to be equal to 2 times 11 plus 16. 2 times 11 is going to be 22. Plus 16, and that is going to be 38. All right, so we also know that since QR is equal to QS, that means QR is 38, and now that means that we can actually say that RS is also 38. So we can say both of these things. If you want to add it to your list of givens, I'm putting in a different color. You are welcome to do that. And since we know that the whole thing, R plus QS is going to be QS, the easiest way to do that multiplication problem is going to be to say that QS is equal to 2 times the length of one segment. But since I did list them separately, we can do it that way. So QS equals QR plus RS. And that means that QS is equal to 38 plus 38, which is 76. So in this case, QS is going to be equal to 76. And again, that's units. They did not give me anything more than that to work with. Finally, if G is the midpoint of segment FH and FH is 6y minus 2, find y. So the first thing we have to do is find x. This one is a little bit more complicated. So make sure that you follow along. And if you need me to slow down, you can either watch the video at a slower speed or you can pause the video. So make sure you're taking your time. So first we're going to list our givens like we've done on every problem. So we are given that FG, well, first let's say we got FH as G is the midpoint. So we are given that it's split in half. So let's go ahead and mark that on the picture first, just like we should. And then we're going to go ahead and go here. Oops. Let's go to our math tool. Because we have the midpoint, that tells me that segment FG is congruent to segment GH. I gotta start paying attention. All right, which means that FG is equal to GH. We also know that FH is equal to FG plus GH. Alrighty. So we know as well that FG is represented by the expression 4x plus 3, and GH is represented by 7x minus 12. So the first thing we're going to do is use that information to solve for x. So since we have our expression here, FG equals F8, or sorry, FG equals GH. Well, FG was 4x plus 3. Okay. And that is going to be equal to 7x minus 12. Right. From there, what I want to go ahead and do is subtract 4x from both sides. Alrighty, minus 4x, and that's going to leave me with 3 is equal to 3x minus 12, equal to 3x minus 12. I now am going to add 12 to both sides, because whenever you do something to one side, you must do it to another. And that finally, that gives us an expression of 15 is equal to 3x. Now we need to divide both sides by 3 in order to find the value of x. Alrighty. And when we end that, we're going to have 15 divided by 3 is 5, and that's going to be equal to x. So 5 equals x, or you can say x equals 5. Again, it does not matter, your preference. All right. Again, it didn't ask me for x, it asked me to find y. All right, remember it asks me to find y. Now, I know that FH is equal to FG plus GH. And I actually forgot to put something in here I did already know. I knew that FH is also equal to 6y minus 2. All right, so we're going to substitute in what we know, and we will actually do 2 substitutions on this one. So just follow along carefully. This one is a little bit different. So first of all, we have our equation FH is equal to GH, or FG plus GH. So the first thing I'm going to do is write that out mathematically. So FH is 6y minus 2. And we're going to put parentheses around that. And that's going to be equal to FG, which is 4x plus 3. Oops, I'm not in my text box. There we go. 4x plus 3. And we're going to add to that 7x minus 12. Now we do, since we already know what x is, we can take our 6y and minus 2 and keep that the same on this side. So 6y minus 2. Will not be changing. I am going to substitute in here. So we have 4x plus 3 plus 7x minus 12. So I'm just going to go ahead and substitute in a 3 everywhere there's an x. Or sorry, 5 everywhere there's an x. So everywhere there's an x, I'm going to replace that with a parentheses and 5. And again, at this point, all I have to do is take this, highlight it. Notice I only go up to the equal sign because the calculator cannot handle having the equal sign in it. It does not like that. So what it'll do is if you have equal sign, I think it might be if you have it at the beginning. Yeah, see, it gives you a warning. You need something on both sides of an equal sign. Interesting. All right, so we get 46. So now we have 6y. And notice I no longer have any x's. I got rid of the x's first. 6y minus 2 is equal to 46. We're going to need to add 2 to both sides in order to find our answer. So I'm going to go ahead and do that. Alrighty. And then that means I have 6y equals 48. I'm going to have to, from here, divide by 6. Why is that so big? One moment. All right. I'm going to start a new line because it's run out. So we're going to go ahead and start with 6y is equal to 48. Then the next thing I need to do is divide both sides by 6. All right. And once I complete that calculation, I will determine that y is equal to 8. So I know that was a little bit tedious. We ran out of room, but there it is. So that's what we have for our segment addition postulate and using the midpoint of a segment in order to solve for x or a segment length. And again, if you guys have any questions, feel free to reach out to me. You have my tutoring hours listed on my website, and I will be happy to answer any questions that you may have. If you need to get a hold of me sooner, please send me an email. I'll see you guys later. Have a good evening, and bye.